Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in MCF 3M who are working on the year-end summative. It's practice question number 5. The question says, a rock is thrown from the top of a cliff on an unknown planet. The height of the rock above the planet's surface as a function of time is given by this equation, where t is time in seconds. I'm guessing m is height in meters. It doesn't say that, it probably should, but let's go with m in meters, height in meters. So we need to determine the height of the cliff. We need to write the function in factored form. How many seconds is the rock in the air before hitting ground, and maximum height stuff. So let's first of all have a really good look at this equation and make sure we understand it. So again, the two things that we're looking at are height and time. So we know that it's one of those typical sort of projectile thrown in the air where we're going to measure time, and at any particular time we can find the height. The equation is given to me in standard form. So that's ax squared plus bx plus c form. So this is the form that when I'm given equations, quadratics in this form, the easiest thing to find is always the y-intercept, or the starting value, because if I let x equal 0, I know that it starts at c. But everything else, there's some algebra I have to do, whether it's factoring, completing the square, or using the quadratic equation. So I know that I probably have some more math to do because it's in standard form. But I have tools like, again, quadratic equation. It actually tells me I have to factor, so I'm guessing I'm going to have to factor it though. So let's just go ahead and jump into the first question. It says, determine the height of the cliff. Now, what's sort of weird is that this is an equation that measures the height of a rock. So it measures the height of a rock against time, and now I'm asked to find the height of a cliff. So it might seem weird at first, but if you reread the question says that a rock is thrown from the top of a cliff. So the top of the cliff on which, so let me just pretend I've got a cliff here. So the rock is thrown from the top of the cliff and then presumably does something like this. So the height of the cliff, which is this distance here, is the same as the starting height of the rock, because at the moment where the rock starts is the top of the cliff, and so therefore if we know the height where the rock is at the start, then we know the height of the cliff. So we need to find the starting height of the rock. Well, the starting height of the rock means we're looking for height, which means we must be able to determine time from the information given. Well, again, the height of the cliff is the height of the rock at the start of its projection. So we need to figure out where is the rock at the start of its journey. Well, the start of its journey is when time equals 0. So we're going to let time equal 0, and we'll be able to find the starting height. So that's a lot of information. Let's look at the next part of it. So again, if this is the first video you're watching, I'll do the math towards the end of the video. Okay, so now it says to write the function in factored form. Okay, so obviously I'm going to have to factor. So just as a reminder, factored form looks like this. So I want to be able to factor out any common coefficients to find an a value. And then I want to factor what remains into distinct brackets. Now, if I can factor it out, I'll be able to find things like the roots or the x-intercepts very quickly. So remember that when you're factoring, always common factor first, and then you're doing that thing where you look for two numbers that multiply and look for two numbers that add. So hopefully that reminds you how to factor, and we'll do that in a minute. For the third part, it says, for how many seconds is the rock in the air before hitting the ground? So again, if we think about what happens with a projectile like this, so we have a cliff, we throw the rock, pew, and we want to know where it hits the ground. So where it hits the ground, well, for how many seconds? So I'm looking for what time it is when it hits the ground, which means I must know h. Well, when something hits the ground, it's literally at ground level, which is when h is 0. So I'm going to let the height be 0, and then solve for t. So how are we going to do that? Well, once I let the height be 0, if I want to solve for t, I now have a couple options. One is I could use the quadratic formula. So let me just show you that a little better here. So in standard form, anytime I want to solve for the independent variable, usually x, in this case t, I can let it equal to 0 and use the quadratic equation. That'll give me two answers which represent the x-intercepts, or in this case the t-intercept. But don't forget, in the previous part of this question, I factored this function. And once I've factored it, I can look here and find my x-intercepts. So I'll have choices when I get to part C, because if I factored, I can find the x-intercepts very quickly. Or I could always go back to original form and use the quadratic equation. So those are your options. And then the final thing we have to do is determine the maximum height reached by the function and what time this height was reached. So determining the maximum, we know that any time in a quadratic situation, when you're trying to find the maximum, you're really looking for the vertex. So to find the vertex, well, in part C, we would have found the t-intercepts. So we would know, for example, that t equals something and t equals something. We would have found those answers when we did part C. So if we think about for a second a parabola, there would be an x-intercept here and an x-intercept here. And the midpoint of those x-intercepts represents the axis of symmetry. And the axis of symmetry passes directly through the vertex. So if I take the midpoint of my roots, by adding them and dividing by 2, I'll have half of my vertex, and then I can just sub that in and find the rest of my vertex. So if you have the roots, finding the vertex is just a couple steps away. You find the midpoint, you sub it in, and then you have both parts of your vertex. Okay, so having now that I've explained how you might answer these questions, I strongly suggest that if you haven't done so already, you actually now attempt to do this math on your own. So pause the video, take your pencil in your hand, and actually do the math now, and see if now knowing how to approach the questions, you can get the right answer. Okay, so let's do the questions. Determine the height of the cliff. So again, the cliff, so I'm just going to represent the cliff here like this, and then here's the ground. We know that the rock was thrown from the top of the cliff, whee, and then it did this, presumably, in a parabolic shape. So the height of the cliff is the same height as where the rock was. So the height of the rock at the start of this journey. And the start of the journey is t equals 0. So if I let t equal 0, and I'm just going to show you the math, even though hopefully you can already see the answer. Again, it's the easiest thing. Oops, I wrote equals for some reason there. One of the only things we can do without a lot of math is kind of answer this question when I have standard form. So what I get is 0 squared times -2, 12 times 0. Oh, and that 32, that c of ax squared plus bx plus c, is the starting height. And again, hopefully you just sort of know that when you have a standard form quadratic, the c term, or the constant term, represents the starting height, or the y-intercept, the vertical intercept. So the starting height is 32 meters, I assume. Again, we weren't given a unit for that. Let's go meters. So if the rock started at 32 meters, then the cliff was 32 meters high, because that's where the rock was. Okay, next question. It says we have to write this in factored form. So we remember that for factored form, the first thing to do is to always see if there is a common factor amongst the coefficients. So all of these numbers are divisible by 2, which means that's a common factor. But whenever the a term is negative, we want to factor out that negative as well. So I'm going to factor out -2, not just 2. And so again, that when I factor something out, it's like you're doing division, but you're not actually changing anything. So that would be t squared, because -2 times t squared would give me back here minus 6t. So positive 12t divided by negative 2 is negative 6t. And again, if I were to go backwards, negative 2 times negative 6t would get me back to this step. 32 divided by this common factor, 32 divided by negative 2 is negative 16. And again, I'm just going to pause here and just double check. Negative 2 times t squared, yes. Negative 2 times negative 6t, positive 12, good. Negative 2 times negative, yay. Okay, so now, I'm not done though. That's only common factoring. Now that I've common factored, I have inside this bracket, I have something in the form x squared plus bx plus c. So I have a standard form quadratic where the a value is 1. And so this means I can do what's called simple factoring. I need to find two numbers that multiply to whatever c is, in this case negative 16, and the same two numbers need to be able to add to negative 6, which is the b term. So now I just need to think about all the numbers that can combine to multiply to negative 16 and check what also multiplies to negative 6. So I'm just going to go through this in the long process in case factoring has always been pretty yucky for you. So if you're never sure, start with 1 and 16, because 1 times 16 is 16. Ooh, but wait a minute, I wanted negative 16. So negative 1 and 16 multiplies correctly, but it adds to 15. So those are not the two numbers. And if I were to reverse the negative sign, I would just get negative 15. So those are not the two numbers I want. And then I say, okay, well, what about 2? 2 times something is 16, right? 2 times 8. So let's try negative 2 and positive 8. If I add those together, I get positive 6. I want negative 6. So I'm just going to reverse the signs here. Positive 2 and negative 8 adds to negative 6. So I have found the two numbers that multiply to negative 16 and add to negative 6. And because this is a simple trinomial, again, simple because the a term is 1, I'm already factored because it factors instantly into two brackets, t plus 2 and t minus 8. And again, just because, I'm done my factoring, but I just want to, since you're here, a little learning here. The reason why this works is if you now do FOIL, which is the exact opposite of factoring. So I'm ignoring the negative 2, but let's just do FOIL on these two brackets. T times t is t squared. T times negative 8 is negative 8t. Positive 2 times t is positive 2t. And 2 times negative 8 is negative 16. So if you'll notice, when I was doing FOIL, the two numbers that are sitting here, the ones that I found, they are both represented here, and I'm about to add them together. And when I add them together, I'll get that negative 6. And then when I multiply them together, I got this negative 16. That's why we have to find the two numbers that multiply to negative 16 and add negative 6. So there you go, little factoring review. But all I had to do was write it in factored form. So here it is in factored form, fully factored with my coefficient out front, my common factor out front, and then two little factor brackets. So next question. For how many seconds is the rock in the air before hitting the ground? Okay, so when the rock hits the ground, I'm looking for the time when the rock hits the ground. And again, this is something where we have a cliff, the rock is thrown up in the air and hits the ground. So when it hits the ground, what time is it? Well, if you're supposed to find time, it means you must be told a height. Well, the height on the ground is 0, so I'm going to let the height be 0 and then try to solve for t. So once you let that height be 0, you now think about, okay, how am I going to do this? So you could use the quadratic equation. So as long as it equals 0 and you have a, where did that go? And you have a standard form equation like I do here, ax squared plus bx plus c, you can take the a, b, and c values, making sure to maintain the positive and negative of each value, sub it into this equation, and because it has both a positive and a negative, we'll get two different answers representing the two roots. And don't forget, one of the roots in this case is probably going to be impossible or negative. You can't have negative time, but every parabola mathematically has two roots. whether they exist for the application of the question. So that's one way you could do it. But don't forget, in the previous question, so I'm going to get rid of this. Where am I going to put it? Yeah, over here. In the previous question, we factored this expression. We already have this in factored form, and it was t plus 2, t minus 8. So negative 2 times this and this. So because it's already factored, I'm not going to use the quadratic equation, because one of the reasons that we like to factor things is because it's very easy to find the roots based on factored form. And again, that's because I have 1, 2, 3 things multiplied together. If any of those 3 things is 0, the whole expression is 0. Now, I can't make negative 2 0 because it's negative 2, but I can make the bracket t plus 2 0. And how I do that is if I let t equal negative 2, so if I put negative 2 here, negative 2 plus 2 is 0, 0 times whatever these guys are is 0, and I have a valid statement. So one of my roots is therefore negative 2. My other root will be when I let this bracket equal 0, and that would be when t equals 8. So if t equals 8, 8 minus 8 is 0. 0 times 10 is still 0. Times negative 2, still 0. So those are my roots. Now, the roots, again, represent where, the places where the height is 0. So if we go back to this little rough sketch here, I've got 2 different roots because there's the actual time that it was 0, and in this case, there's the symmetric time, but it doesn't exist in the actual rock problem. But algebraically, we need it. Still, which one of these times makes sense? Well, obviously, 8 seconds later is when it hits the ground because it's not going back in time. So in 8 seconds, after being thrown, the rock hits the surface of the ground, or it has hit the ground. And we would have got the same answers had we used the quadratic equation. It's just that because it was factored, that seemed faster. And then finally, it says determine the maximum height reached by the function and what time this height was reached. So we know that we're looking for the vertex. And we already have the roots. We already know that the roots are at negative 2 and 8. And if we have the roots, we can simply find the midpoint of the roots. And the midpoint of the roots, the midpoint of the roots, in this case, negative 6 divided by 3. And that means, if we just sort of visualize again what we had, here's the kind of a cliff. The midpoint of the roots is where the axis of symmetry is. And the axis of symmetry always passes through the vertex. So I know that my vertex is at t equals 3, because that's the midpoint of the roots. Now, that's not the maximum height, though. That's just the time. So to find the maximum height, I now let t equal 3 in the equation, and I do the math. So the height at 3 is negative 2 times 3 squared, plus 12 times 3, plus 32. You can, of course, use the factored equation as well. Sub 3 in there, you'd get the same answer. So negative 2 times 3 squared. Well, 3 squared is 9, and 9 times negative 2 is negative 18. 12 times 3 is 36, plus 32. So I have negative 18 plus 36 plus 32. So if I add those all together, sorry, I think I'd be able to do this in my head. I've been doing math for quite a while, but what can I say? 50. So the height of the cliff is 50 meters at the vertex. So if you want, remember that your vertex is xy, in this case, time and height. So the vertex is 350. So I know that at 3 seconds, we've reached maximum height. And the maximum height is 50 meters. And that answers both parts of this question. It says, determine the maximum height reached by the function and what time this height was reached. So the maximum height was 50 meters, and it was reached at 3 seconds. So I hope that this video was helpful. Good luck with your study.